Alrighty, so in this video we're going to take a look at resistor combination, so combining resistors in series and parallel and then kind of a mixture of the two. So first of all, what we're going to do is we're going to draw a circuit diagram of the circuit used to measure the resistance of two resistors in series. So let's actually open the right thing. So the first thing to remember is what resistance actually is. So resistance is potential difference divided by current. And the way I think of resistance is I think it's the potential difference required for a current of 1 amp to flow. That's how I think about resistance. So if we want to measure the total resistance of two series resistors, we need to know what the potential difference is across the two resistors and the current going through the two resistors. So this is the circuit that we need. Now we could have the ammeter over here, up here, it doesn't matter. The ammeter as long as the ammeter is in series, it doesn't exactly matter where it's located. The voltmeter must be in parallel with the resistors. Okay, so let's hop back to our quiz. Okay, so if the current is 0.44 and the potential difference is 4.92, what is the total resistance of the series resistors? So we're going to be using our equation for this. So let's take a look. So we're doing the potential difference. So this 4.92 is in volts, so that's our potential difference. 0.44 is in amps, so that's our current. If we actually calculate that and type it into a calculator, it will come out with 11.18 blah, 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 blah. So we have to decide how to round our number. So we need to look at the significant figures of the data in the question. So the 4.92 we would say is a 3 significant figure number. The 0.44 is a 2 significant figure number. So we should round our answer to the smallest number. So we're going to round our answers to 2 significant figures. So if we hop back here, so that's why I put in these two here to see who would know to round to the correct number of significant figures. So we should be putting 11 because we round to the smaller number of significant figures. So we round to 2. Okay. So if the resistors are 9 ohms and 4 ohms, what theoretically should we expect the resistance to be? So the general rule that we're using is for series resistors, we just add together their resistances to get the total resistance. So here, we'd expect to get a total resistance of 4 plus 9, so we'd expect that it should be 13, but given that we're doing an experiment and there's always some uncertainty around that, as long as we're getting close. So we got like 11, so we're getting pretty close to that. Okay, and in terms of explaining how we got our answer, this is the key that we're showing that we're essentially adding the resistances together here. Because when we add more and more resistance in series, that decreases and decreases and decreases the current in the circuit. And so if we're getting a smaller current, that's a higher resistance essentially for the same potential difference. Okay, so moving on. So now we're looking at a diagram to draw the resistance of two resistors in parallel. So let's take a look at that. So it's very similar to the previous one, except this time we've got our two resistors shown in parallel. Voltmeter is still connected across both of them because we want to know the potential difference across both of them. We could have actually shown the voltmeter just in parallel with one of them. That's exactly the same, so that would be fine. And the ammeter measuring the current that's going through both of them. So that's the circuit that we need. Okay, so if the current is 1.6 and the potential difference is 3.64, what is the total resistance of the that should say parallel. I don't know why it says series. I'll fix that in a second. So again, we're just using our equation here. We're just doing V over I, and we're getting 2.3 ohms. So we don't need to do anything more complicated than that. What can we say about the total resistance of parallel resistors compared to the resistance of each of the individual resistors? So the total resistance we got is 2.3. Whereas the resistors that actually went into it were 4 and they were 9. So the total resistance of parallel resistors is always less than any of the resistors in the combination. So we had a 4 and a 9, so the total resistance we know is going to be less than 4. And the reasoning behind this is that as we add more and more resistors in parallel, we increase the current that's coming out of our battery. And if we have the same potential difference but a bigger current, that means we've lowered the resistance. And we do actually have an equation to figure out precisely what would happen, but this is a good general rule to know. We always expect a resistance less than either of the individual ones. So next we're going to look at what is the actual resistance supposed to be theoretically and why it is that, which is the follow-up question. We want to know why we got that. So when we're adding them in parallel, this is the rule that we use. So I often refer to it as the reciprocal rule because we're adding together the reciprocals of resistances. So here we've got 4 and 9 ohms. So when I'm adding fractions, obviously we need to find the common multiple. So that would be, the first one is 36. So 1 over the total resistance is equal to 13 over 36, which means the total resistance is equal to 36 over 13. Essentially, I've flipped both sides over, which is 2.7 blah, 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 or 2.8 rounding that off. We could justifiably actually round that to just 3 ohms to give it to the right number of significant figures, in fact. Okay, so that's how we get that one. With parallel resistors, we do the reciprocal rule. So if we have the 4 and 9 ohm resistors in parallel, and then have the 8 ohm resistor in series with the power supply, what theoretically should the total resistance be? So let's have a look. So I've actually drawn a diagram of what this looks like. So obviously there's a power supply in here too, but this is what the resistor configuration looks like. So the first thing I'm going to do is combine together these two parallel resistors. So I think a fair question to ask is, why don't we combine the 4 and the 8 or the 9 and the 8? Because a lot of people say, well, aren't those in series? Can't we add those together and get 12? And the answer is no, because the 4 and the 8 or the 9 and the 8 are actually not in series with one another, because if a charge goes through the 8 ohm, it doesn't have to go through the 4. It could go through the 9. So actually these two are not described as being in series, but these two are definitely in parallel. Because if a charge goes through the 4 ohm, it doesn't go through the 9 ohm. That's how I think about it. So that's why we're combining the 4 and the 9 together first, because they're the only ones that are actually in either series or parallel. And we actually calculated the total resistance of those in the previous question. So we know the total resistance of these two is 2.8, which means this circuit here is the same in terms of resistance as this circuit here. And this circuit here is easy to deal with because now any charge that goes through the 8 ohm has to go through the 2 ohm. So these two are now in series. So we can add them together, and that's where we get this value of 11 from. It's actually like 10.8 blah, 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 but we'll round that to 11 to be sensible. Okay, so that's where our answer comes from, and that's how we arrived at that answer. And then finally, to finish off, just summarizing a couple of general rules that it's worth knowing when we're doing calculations so we can check how sensible our answers are. So if we add resistors in series, that has the effect of increasing the total circuit resistance. And if we add resistors in parallel, that has the effect of decreasing the total circuit resistance. Two general laws it's very useful to know.